Okay, so for problem number 7, what they're asking you is to take this 24-inch by 24-inch piece of cardboard, and you're going to cut it so that you have this open rectangular box. And what they're asking you to do is find the dimensions of the for the largest volume of this box, and what is that volume. So the nice thing about this problem is that they are actually they give you the 24 minus 2x, so volume is just length times width times height. So what we have is 24 minus 2x times 24 minus 2x, because that's the length and the width, and then the height will be x. Okay, and so now what you're going to do is you're going to go ahead, and what I would encourage you to do is multiply this, because what they're asking is they're asking for the largest volume. Okay, so calculus speaking, they're asking for a maximum. So we are going to need, if they're asking for a maximum, we're going to need the derivative, and it'll be a lot easier to take the derivative if we go ahead and turn this into a polynomial. And so when you multiply, you should have 576x minus 96x squared plus 4x cubed. So it's a lot easier to find the derivative of this polynomial. If you took the derivative of this, you would have to use the product rule twice. So I don't want to do that. Now, dv over dx here, what we have is 576 minus 192x plus 4x, plus 12x squared. Okay, so what we are going to do is we are going to apply the first derivative test here. Now remember, this is an optimization problem. This is not a related rate problem. That's why I have dv over dx, not dv over dt. Okay, this is optimization. Okay, so I'm going to apply the first derivative test. First thing you have to do here is you have to find the critical numbers. So you take the first derivative and set it equal to 0. Very nice thing here is that you don't need the quadratic formula, because this is factorable, and it might be easier to see that it's factorable once you simplify by 12. Okay, so simplifying by 12 will give you the derivative of 48 minus 16x plus x equals 0. Okay, and now this is, if you want to rearrange this to x, that's x squared. So x squared minus 16x plus 48 equals 0. That's fine. And then factor it this way. Okay, they both work, but nonetheless, when you factor, you should have something like this. And so you have x equals 12 and x equals 4. Now remember that x equals 12 cannot be in the domain. X equals 12, when you plug this into your volume, that will produce a volume of 0. Okay, volume of 0 does not exist. That's not true. So x equals 12 does not work. So x equals 4 is our relative maximum. And we can confirm that by taking the number line that represents f prime. Okay, we're going to plug in x equals 4, or the critical number that we have, and the test values will be 3 and 5. That's what I'm going to use. And notice that when you plug this 3 and the 5, when you plug them into the first derivative, okay, it has to be to the first derivative, then what you do is you take the sign. It's positive and then it goes to negative. So what that verifies that x equals 4 is the relative maximum. Okay, so then what we have is when x equals 4, we go ahead and plug that in. We're going to go ahead and plug that in to the length, which was 24 minus 2x, so that'll produce 16 inches. Width is the same thing, so it'll be 16 inches. And then the height, oh, that's not the correct height. The height was just x. So the x will be 4 inches. So the height will just be 4 inches. Okay, and then finally, volume is length times width. So here's the answer. If volume is length times width times height, I'm sorry, I forgot the height. Since volume is length times width times height, this volume is going to be 16 times 16, and these are inches, times 4. So the volume will be 1,024 cubic inches. Okay, so these are the answers for problem number 7. These are the dimensions. Alright, and that's how you do number 7.